So today I'm going to show you an example of how to conduct a related samples t-test using SPSS. So I'm going to give you an actual example research question and some example data that we're going to work through to answer our research question. So one thing to note is that related samples t-tests are sometimes also referred to as repeated measures or also within subjects t-tests. So those are all referring to the same type of analysis that you're going to be learning about here. So the situation in which you might use a related samples t-test would be one in which you're comparing two different time points to each other. So one of the big things to remember is that the thing that distinguishes the independent samples t-test compared to the related samples t-test is that the related samples t-test, it measures the same group of people 2 times. So that is the major distinction, is that it has that within subject sort of design where the same group of people are measured under 2 different conditions. So here's an example that uses that type of setup for the research project. So in this research question, we have a researcher who wants to know whether there's a change in the amount of candy that people eat during the month of February compared to March. And so to test this, he asked students how much candy they consumed during 1 week in February, and he asked them the same question again during 1 week in March. So we know it's a related samples t-test since it's the same people that were measured on this variable that's on an interval or ratio scale. They were measured on that variable at 2 different time points. So we're going to use a related samples t-test in order to test this hypothesis. So now I'm going to show you how to do this in SPSS. So to do this analysis in SPSS, you obviously have to have a data set that you have data in to work with. So here is my data set that represents the measurements that were collected by this researcher. So in this data set, what you will do to do the related samples t-test is you'll start here at the Analyze drop-down menu. So that's going to be where most of our analyses are going to be in SPSS. And the option that we want to select from here is compare means, because we're trying to compare how people's mean difference score changed. So how much they changed over time is essentially what we're trying to test here. So to do that, we're going to select this option that says paired samples t-tests. I know I just told you a bunch of different names that are used to refer to this same type of t-test. So here's another one we can add to the list, the related samples t-test, also sometimes called paired samples t-test. So we're going to select that option here. And let me move this window so you can see it. So this is what our window should pop up to look like. And it should start out empty. So when you're here, what you want to do is, a lot of times I like to switch the view of these so that it's easier to look at. So you can choose between displaying variable names or displaying the variable labels, whichever is easier for you to find what you're looking for. So I'm just going to switch that to the variable names. And so one really important thing to remember when you're setting up this test is that you need to do the after first. So March happens after February. So I'm actually going to select the score for March first and then use this arrow to move it over into the box. So you'll see it automatically goes under that variable 1. And then I'm going to take the measurement for February, and I'm going to go ahead and use the arrow again. That'll move it into that variable 2 box. So the reason why we do the after first and then the before is this will help us see the direction of the change. So if people's scores are increasing over time, then the change will be positive. If people's scores are decreasing over time, then the result will be negative. So that's why we always will do after first and then before second. And from here, we're just going to click OK, and you'll get your output. So here's the output that we get for our related or paired samples t-test. You'll notice in this first box here, we have our descriptive statistics. It splits up the average amount of candy consumed during March and the average amount of candy consumed during February. it should always have equal ends because it's the same people being measured twice. So those will always be equal. So those are the main things we might be interested in that box. Really, frankly, I never use anything from this paired samples correlations box, so we can kind of ignore that. The main box that we want to look at for this analysis is going to be here in this paired samples test. So this is going to be the primary location of most of the stuff that we're going to need for our analysis interpreting our paired samples t-test. So I'm going to walk you through how to look at that output. All right, so I've just copied and pasted the primary output that we're going to use for this analysis into this PowerPoint slide to make it a little bit easier to look at. So as I mentioned before, these are the two tables that we primarily want to focus on in our output for our related or paired samples t-test. So let's talk through how we're going to interpret this output. So the same rules are going to apply for almost every analysis that you're doing in SPSS, where you primarily want to be focused on this column that's labeled sig. The reason for that is your sig value is your p-value. So remember, your p-value is what we always compare to our alpha level. So in any situation where you have a sig value, which again is just our p-value, anytime that value is less than whatever your alpha level was, in this case we were asked to use an alpha level of 0.05, so if we had a p-value or sig value that was less than our alpha, then the decision would be to reject the null hypothesis, meaning that there's a significant change. If instead we had a sig or p-value that was bigger than our alpha level or equal to our alpha level, then our decision would be to fail to reject the null hypothesis. And that would mean that there is not a significant change. So we're just going to take this sig value that we obtained in our analysis here and compare that to our alpha level of 0.05. And so in looking at this number, 0.661, we know that that value is bigger than 0.05. So that would be the situation in which we have a sig or p-value that's bigger than our alpha level. And so because our sig value, our p-value, is bigger than our alpha level, we're going to make that decision to fail to reject the null hypothesis. And again, what that means is that there is not a significant change. So our decision here is to fail to reject the null hypothesis. And when thinking about how to write up our conclusion in APA style, we want to basically just reflect what we were testing and what our decision was in this hypothesis test. And so the way we might write our conclusion, so again, usually one of the easiest ways to write your conclusion is to take that question that you were asked in the first place and just reword it in terms of an answer. So I did that to start my conclusion here. So I'm going to start my conclusion by saying there was not a significant change in the amount of candy people ate during the month of February compared to March. So again, since we failed to reject the null hypothesis, that means we did not find a significant change in the amount of people, the amount of candy people were consuming. So you will notice though that I've reported the M subscript D. That reflects the mean difference score. So in the related samples or paired samples t-test, primarily what we're interested in is how people changed over time. So the mean difference score reflects the average amount of change that people had from March to February in terms of how much candy they were consuming. And so you'll find that mean difference score right here in the paired samples t-test box. You'll also notice that I rounded that to 2 numbers after the decimal point to comply with APA style. And then next we want to report our test statistic that we used to reach this decision. And so we use T in this analysis to make that decision. And in parentheses next to the T, so the T is italicized and so is the M. So the T next to it goes our degrees of freedom in parentheses. So you'll see that our degrees of freedom are reported up in our T table. So you got our degrees of freedom of 64, and then our T value also reported up here is 0.44 when we round that to two numbers after the decimal. Since we made that decision to fail to reject the null hypothesis, we end this conclusion with these two letters NS in italics, representing that that test was not significant. So we typically, if we did have a significant effect, then we would have calculated effect size. Since we did not have a significant effect in this analysis, we won't include the measure of effect size, because those non-significant results, they basically mean that there is no effect. So I just wanted to talk about how to calculate effect size in case you do have an analysis that has a significant effect. So if you did have a significant effect, you should know that SPSS does not calculate measures of effect size for t-tests. I have no idea why, but that's just a reality. They don't give you the measure of effect size. There's no option to even select for to get it. However, it's very easy to calculate this measure by hand. So in calculating the measure of effect size for a paired or related samples t-test, all we do is take the mean difference score and divide it by the standard deviation. So that's what that symbol represents in that formula. We also take the absolute value of that, so it doesn't matter if it's positive or negative, we just ignore the negative sign if there was one. So all we would do from this example, had we found significant results, then we would do this calculation. But since we didn't, I'm not going to do it. But this is where you would find the information in the table that you would need to calculate your Cohen's d. So Cohen's d, you'll just take that mean difference that's in that paired samples test table, so the green circle, and you'll just divide it by that yellow circle that I circled in the table is your standard deviation. So you just divide the two, and then again, if there was a negative sign, you just ignore that. You don't report the negative sign. So remember that you'll only give your measure of effect size had we found a significant effect, which we did not in this example. So in the example that we had on the last slide, we are just going to leave the end of our conclusion like this. Whereas if we had a significant effect, then we would add the measure of effect size after at the end of our conclusion. So that is how we interpret our analysis for related samples or paired samples t-tests using SPSS.